Chết một basic basic program này. Dạ chắc đây đây có đồng tiền. อ๋ออ๋อเช็ดเช็ดเช็ดแต่ว่าไอ้
Settle down, please. Good news that today is Friday. Weekend is coming.
มายสวัสดีครับ
Good news.
มายสวัสดีครับ
Okay, let's just revise a little bit about our previous lesson. Can you settle down? Someone who's late, please be quick. Settle down quickly. Okay, now please give me some keywords. Let's just remind about the previous lessons. What did we discuss about? I think if someone you answer the question, you will remember. Keyword, please. Again, I heard someone say if else. Good? If else.
Why?
Why? What are they? structure, right? How many structures that we mentioned last time? How many structure in programming that we mentioned last time? How many are they? 3, yes. The sequential structure, one statement outcome after another, and then conditional, the branch structure that we need to check for some conditions in order to decide what to do next, make decisions, right? And the loop, yes, loop. And in the loop structure, we mentioned about for loop, do while loop, right? That we repeat some statements or some group of statements or executed again and again until some condition is met. And talking about range, structure, and loop, we need to understand about what is it? Logical expressions. Okay? So I think you have already some practical session.
Yes.
Right. To practice about how to use if else, nested if, and the for loop. And inside talking about for loop, there are several terms you need to understand, which are the iterator. The iterator or iteration variable, iterator, some condition, increments, decrements, etc. Okay, so that was the previous sessions. We mentioned about structure programming, talking about flows, control flows, using if, else, for loop, do, while, etc. And I remember in the last few minutes of the previous lessons, I have mentioned about this for today content. We're talking about functions. Functions. And what are functions? Functions. Actually, we try to answer the questions. Let's say there are many problems in daily life, right? From the simple to the complex ones. For complex problem, if we want to write a program that solve these complex problems, we will need thousands of lines of coding. What is the longest program that you write? What is the length of the longest program that you wrote till now? 16 lines. 16, okay, 16 lines. Do you remember for the first section we mentioned about coding convention? What is the maximum length of a file? To write the code inside a program, it contains a lot of codes, right? And do you remember in the first session we mentioned about coding convention? What is the longest length of one file that you can write code in? Do you remember 78 or 80 lines? Okay. And for a program we need 1,000 lines of codes, and the question is it possible to arrange to write 1,000 lines of code with mixed to make within only one
program.
no, it's one program, but within only one file.
One file in the task we have to organize.
Yeah?
I think
It's possible, but it shouldn't. We shouldn't do that. It's hard to arrange everything in the same place.
that's
For example, where do you keep your clothes at home? In a wardrobe? Yeah? Wardrobe? Not in a box? Under the bed? No, just kidding. Normally we keep our clothes in a wardrobe. And let's imagine we have many types of clothes. And I count also for the shoes, socks, many types of clothes. If you keep them together in the same box or in the same wardrobe without organize them, it will be a mess. It will take you a lot of time at the beginning of the day to retrieve some shirts or shoes to prepare for the day. So let's say it's better that you organize, you classify your clothes into types and arrange them, organize them inside the wardrobe. Maybe you may want to keep them in separated box, one box for shirts, one box for chargers, etc. And one area for only shoes. And the same here. When you want to solve a complex problem that requires you to organize a lot of codes, you have to make decisions, many decisions inside the program. The question is how to organize them. It's like you organize your clothes inside a wardrobe. Any idea for these questions? Let's say we have 1,000 lines of code with mixed structure. How to organize them in a big program? How to organize them? Last time I mentioned, you have to chop it. Yeah. You have to chop the problem into a smaller piece and solve it. And this is the idea of the function. So for today, we talk about how to chop a big problem into the small one and organize them. We're talking about the top-down design. It's the idea of the top-down design. Cut down, chop, separate big problem into the small one. And then we apply the idea of the functions in programming. Now again, we have large problems. Large problem. It takes, it may be highly complex and it takes a lot of computations and hard to implement. Right. So we break the problem into tasks and tasks into subtasks. Tasks. task into subtasks. And each subtask should be less complex than the bigger one, right? And lighter computation, easy to implement, etc. Just help you to manage is easier. Right. It's like nowadays you can solve complex problems, so complex equations, quadrature equations. But you have to start from learning the additions and the multiplications, and then you solve a complex equation in the same. Okay, and now you can imagine that for each of these subtasks in the problem, you can manage it as a function. And the definition of the function is actually a group of statements. Group of statements that perform specific tasks. And each function must have a name. A name. The goal is to divide concord. It's familiar. It's maybe some game. Divide. Now, what is the advantage? Whenever you chop down the problem, you can deal with the small one. This small one, smaller one, is easier to deal with than the big one. It's like the previous example mentions. If someone who's familiar with marathon, you can run 10 kilometers per day. This is normal. But for someone who always walk and haven't practiced to run for a long distance, 10 kilometers, I ask you, today please run 10 kilometers. You will feel very afraid of this. Really don't want to do this. So it's better that every day you try 1 kilometer. With 1 kilometer is less, it's easier compared to 10 kilometers. And the same here. When you chop the problem into the smaller tasks, it's like 10 kilometers. You chop it into 1 kilometer per day. And then next month, you will increase 2 kilometers per day, etc. Now, the advantage of function is that it helps you to keep the program smaller, easier to read, easier to modify, easier to debug, check for the bug. It helps you to manage the code, and it's reusable. It means for some function you can apply it in different problems. Okay, and it's reduced the repetitions of the code. Repetitions. What codes? For example, to compute the factorial of the number. If you want to compute the factorial number of 3, for example, you have to multiply 1 by 2 and then multiply by 3. So if you compute factorial 2, 1 multiplied by 2, and then repeat compute for 3, it's the repetition. So it's better that we use the factorial 2 for the factorial 3. etc. function. Takes time for you to feel the advantage of function. Okay, for us, function is the structure of functions. You can imagine a function as a black box. Okay? You feed it with some inputs, which we call parameters. And then you compute some function of this input and return the result. This result we call as output, and in this case called as return value, return result. Let's say, for example, we have f(x), a function x, example of a function. Let's say consider f of x. This function is familiar to you, right? It's equal to 3x plus 5. So we have a function f of x. What is the input for this function? X, yes. So if we call this a black box, it's function of x. The input is x. What is the output? The output is f of x, right? Equal to 3x plus 5. And let's say if x is 3, what is the return?
X is equal to 14.
To
14.
14. 14. Okay, so this is an example of functions that is familiar to you. And now you can imagine in programming, we create some code, create a function, and it needs a name. And let's say if we consider x is an integer. If x is integer, what is fx? What type of fx? What data it should return? It's also integer. Okay, so in programming, the syntax is something like this. The return data type. This is the return result. The data type of the return result. And the name of the function. In programming, you cannot write f of x, but you have to name it. Let's say I call this f, or I call this function, or function example. This should be example. This is the name of the function. And then you have to define the input. You have to define the variable and the data type of the variable, that input. And inside, you can create like f, you call f is equal to 3 multiplied by x plus 5. And then you have to return what you want to return. Return f. This one is int, integer. Okay? So now you are clarifying about the input, output, and the name of the function. This is what I'm trying to say over here. An example over here. In this example, how many inputs? In this example, how many inputs? There are 2 inputs. The x and the y. And we have the function name is add. You can name it any name, but it's better that the function name reflects the contents or the task of the function, right? And the value is returned, should be an integer. In this case, return the additions of x and y. Return the addition of the 2 inputs. Okay? So sometime I will ask directly what are the inputs of the function. But the correct term, I always ask what are the parameters of the functions, or what are the arguments of the function. Function will have arguments, function name, and return type. Function, return type, name and parameters or arguments. And a function may have no argument or many arguments. Okay? Sometimes you see the name of the function and the parameter is void. So the function has no arguments. And the return type, any data type, or is return nothing. We don't need a return value in some case. Right. Actually, you have been using function in C. For example, printf function, scanf function, right? They are functions, predefined functions in C. They call the built-in functions. It's meaning some function that exists and you just call it and use. Now, do you remember printf function? How many arguments that the printf function have? How many arguments? Or how many parameters that function printf has? How many? How many? Many. It depends. It depends. It can have at least one argument or many arguments, depending on how many value you want to print out. Right? What about scanf? 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 The same to printf. You can input from the keyboard many values. Right, and in order to use this built-in function, you have to include the library that defines this function. In case you want to use printf and scanf, you have to include the stdio, it's actually standard IO library. By include stdio.h, right? And maybe you have tried sqrt. What is sqrt function? Yes, it's return the square root of a number, right? How many parameters that does it have? One, square root of a number. POW, P-O-W. Power, yes, exponent. How many parameters? Two. So the base first or the exponent first? The base first and then the exponent. Yes, that's good. And to use these two functions, you have to include the library named math, math.h. This is actually the file that defines the function itself. Honestly, I cannot remember all the functions that exist in C. However, you can check for the function, like the return data type, how many parameters, what are the data types of these parameters in the library. Provided that you know where is the library that defines the function itself. Some functions that exist you can use, but we encourage you to write your own function. Now the second type of function, this is what we want to practice. If you want to compute, let's say, if you want to compute the average GPA of our class, let's say you input on the GPA of 680 students. And in order to compute the average GPA, you want to write a function to compute this average value. And this time you can define your own. the average. How can we compute it? Questions? Let's say if I want to compute the average GPA of 680 students by a function, how many parameters do I have? Should I create to compute average GPA of 680 students? How many parameters? 680? Not really, not really. Next lessons, you will study about array. Array is a data type that you can store many values, and you need to input only the array, only one parameters for the function. Only one, or maybe two, if you have to, if you vary the size of the number you want to compute. Right? And to define the function, you will have to do something like this. Firstly, you have to define the function. Declare and define. Declare is mean you say, okay, I name the function. Firstly, you have to name the function and set that. And declare that there exists a function with the function name that return the data type like this, and that has the parameters like that. Is a declaration. And then you have to define the function. It means define. You have to list out what are the statements inside this function. What does this function do? Okay, so this is declaration, definitions of a function, and then whenever you want to use this function, you call it. Call by name. Call by name. Right. Now, later I will describe in detail about this. Talking about the existing function, there exists some standard libraries that you can use the exist function. Some common libraries you often use stdio, stdlib, math, right? Next week we will study about string, float, some type float, syntax, etc. But normally you use stdio, comio. If you have to work with to input output to read and write some file, mathematics function, and along with strings. Okay. For all detail about this library, you can check. You can search for this. Right. As I mentioned, I think you hear about this several times. The teacher, the lecturer always asks you, please define everything before you're talking about this. Give the definition before you're talking about this. The same thing. Understand about the terms before you study further. And the same here. Let's say you want to compute the average GPA of 680 students. So firstly, you have to define the function itself before calling it. It's like this. The syntax. over here, right here, we are studying about programming language, C. So we often have to talk about syntax. It's mean about vocabulary and grammar. This one is grammar. In order to declare a function, you have to firstly state the return data type. The data type of the return value. I think I should call someone. Okay, I will describe and I will ask you later. For the syntax, firstly you have to state about the return data type, and then the function name, and then the list of the parameters inside a pair of braces. And talking about parameter lists, you have to declare the data type of each parameters and the name of the parameters. And then the function, the body of the function, must be kept inside the parenthesis. This is parenthesis in the braces. Keep inside the pair of braces. Besides. Now again, if you want to compute the average GPA, so please name the function that related to average GPA. Don't name some name like Hương or Minh or whatever function name like this. It doesn't reflect the content of the function. So by convention, please choose a verb a verb that reflects the meaning of the function. Now, and you have to define the input, the argument, let's say, it's quite complex here. I have a question for you. Now, let's say I have a function named int of function name function increase int x and return x plus 1. Now, first questions. What is the return data type? What is the function name? How many parameters? And what are their name and data types? Linh Hồ Phú Cường. Cường, are you here? Phú Cường. Action. Dung. Đào Quý Dương, action. Phan Thanh Giáp, Jack, are you here? Okay. Please, can you see it? This is the functions that I define. Can you see from here? Over here, the right text. Okay. Could you please tell me what is the return data type of this function? What is the function name? What is the function name?
Function integer. Increase. Yes. Increase.
Good. Thank you. Now, let's say if I initialize that x is 5. Let's say if x is 5 in int is a is 5, and then I call later increase a b. Sorry. I shouldn't. B, int B is increase of A. So, what do you think? B is equal to and A is equal to? Questions. Let's say I initialize a variable named A. A is equal to 5. I define a function increase like this with the name input and return data type like over there. And I call the increase function of A. B is equal to increase of A. And the questions after all these statements. What is the value of B and what is the value of A? B is 6, good, and A is 5. No, it's not 5. But B is 6 is correct. Now, can you guess what is the value of A? A is 1. Again, sorry, look, you said A is 5. Yeah, it's correct, sorry. It's correct. It's my problem. A is 5, it's correct. What about X? Yeah. You cannot call X because the scope of the variable X is only inside the function. Outside of the function, you cannot call x. Okay? X is not global function. X is just, X is not global variable. X is just a variable that has a scope inside the function. You see, X is declared here inside the function. So the scope of X is inside the function only. And you cannot check or access to X outside. That's good. And so you can answer the function doesn't change the parameter value in this case. However, in another case, if you call by pointer, it may change. If you call, this one is we call by value. Later, I will explain. And remember, the function cannot be defined in another function. Like this. It's better that I denote something. Right. Maybe later. Now for this example, we have a function here. And we call it the function by the name. A function cannot be defined inside another function, but can a function call another function inside itself? Yes, provided that the function is defined before. Now for this example, I want to ask, what is the return data type? What is the input? What is the name of the function? Check the list. Check the list. Phạm Ngọc Trường. Okay. Can you tell me some detail about this function? What is the return type? Void. So it's return. What is return? What does this function return?
Return the hello from return.
Not really. The hello from function is actually the printf actually what is does? What is return? It's return void. It means return nothing. Right. And what are the inputs? You can see from here, for this function, you don't need to input anything. And it's return nothing. It's only do some task. And the task here is print out hello from a function. Okay, and and this is how you call the function itself. Call by name. Call by name is not really, it has another meaning, but later I can explain. A few minutes break, 5 minutes. Okay. Refresh and come back. Continue. Have you tried to create some function in your laptop and run? You try this?
Do we in a class?
Let's try. If you include, let's say, in this program, I have created two functions. The say hello and say goodbye. Say hello and say goodbye. They don't have arguments, have no arguments or no parameters, and return nothing. And let's say you can call the function in the main function. Right? And you can check. And run it. Let's say I call only the say hello. Say hello. So only. So only the text, the string from the say hello function is printed out. And now you can call the say goodbye. To call the function, just give it the name and input some parameter if you want. Okay, and compile it again. Run it. I should add some. Okay? One by one the function is called. So this is the example of how you create the function and call the function. Now another simple function. From these lines of code, can you list down the name of all the functions in this program? Call the name. All functions in this program and the detailed function. Nguyễn tự Lan Anh. Lan Anh. Okay. Can you list out the name of all the functions in this program and describe this function? What is its function? What does it do? Okay. This function is addition. Two. This is it there are number one and number two. This function from we sum number one and number two. Number one and number two. Thank you. So over here we have a function named addition, which has two inputs, two integer and return the summations of these two inputs. You can try this code, run it, and see over here. So you're familiar with the printf and scanf function to input a value, okay, and call the function. Now you will see, call the function. We didn't mention about this. Over here, addition, var1 and var2, not num1, num2. I hope you distinguish between num1, num2 and the variant var1 and var2. Num1 and num2 here, they are the variables that created and used inside a function, the function. And the var1 and var2 are the variables, the variable that you create and use it in the main function, and you call the function by input only the value of the variable var1 and var2. Input the value, and this method, this manner, we call it call a function by value. Where is the call the function? This later, call my value. Right. And previously you see the function definition, declaration, and function call are in the same file. But let's say there exists a term called function prototype. Prototype. What is prototype? Prototype. Prototype is like black box. Prototype. It's like you consider this as a black box. Sometimes you use it and no need to look inside the function. It's like the same thing like you use sqrt to compute the square root of a number. You don't have to look inside the function sqrt. What is it? What are the statements inside? But you can still use the sqrt to compute square root of a number. It's the same here. Then this is called a prototype. And you can declare a prototype of a function using the syntax, return type of the function. Function name are the same as function definition, declaration, but you end it with the semicolon. And you define the function in another file somewhere, hiding the code away. Something like this. Over here. If you keep the program only till this point without the declaration, the compiler will show you the error. However, you will see, you call the function, say hello, but haven't defined it before. Why define it later? Define it later. This program still runs because you already declared a function function prototype a function named say hello. And the main function just when it's called, it will look for everywhere that it can for the definitions of the function. You don't need to specify it before calling the function. And using this prototype to keep the code nice and neat, you can keep the function declaration definitions in another file, in a separated file, to keep the main function very nice, very neat, easy to read. Something like this. You can keep the function declaration in another file, you can name it .h, and then include this file, this header file in the main .c file, and call the function. You can try it. So we distinguish between the header file and the implementation file, .h and .c. Okay? And so by using the header file, you can hide away the code of the function, some part of the code, and still can use the function. Alright, when you include the header file at the beginning of the program of the file that contains the main function, the OS will compile all the included related files. You can try it, like keep them in the separated file. For example, you can keep in the main function, you call the say hello function, but you didn't define it. However, you see here a header file say hello.h, and in say hello.h you define the function prototype name. You declare only the function. And where is it? Dots. And in say hello.c, say hello.c, you declare, you define the function. Okay, and because you keep the header and the implementation file in two separated files, so when you compile to make the program run, compile and want to run the main function that called the say hello, you have to make a link between the header and implementation file. You can compile it. So in GCC you have to compile all the complete implementation files. create an executed by name test function that links between these two. That's not done here. Okay, you see the result here. Hello from function. Why in the main function? You have only say hello. Okay, so I have introduced you 3 cases of using the function, call the function. Either you can keep 3 cases to organize the code of the function. Either you can keep all the code inside a file, all the function declaration, the function call inside a file. You can use a function prototype inside a file. Or you can keep the function declaration in separated file. And normally when you work with a project and in some professional team, they often organize code as the header and the implementation code, the .h and .c. And in order to compile the .h and .c together, you have to compile all the implementation file. Output is as a binary file format. Executed file. And last year, among 630 students, there are only 5 students who can organize the code into separated files like this. All 625 other students even don't understand the questions of how to organize the code into separated files, how to use function groups. I hope this year, among 680 students, some of you may answer it. I want to give up my hope. Now, for the part of calling of functions. Again, before calling any function, you have to declare it. And if the function is existing existing one. You can call it with the standard library. So you have to include the header file that is kept inside the symbol. These two braces, triangle braces like this. Header file for standard libraries. For user-defined library, you have to keep the header file inside the double quote. Right, for codes, and I have demonstrate how to code it, code by name, and provide the parameters, values for the function power, to power 3 in this case. You have to provide the two parameters. Okay, so previously we mentioned about how to call the function. Use its name and followed by the parameters. Call by function, you provide parameters. And when you're providing parameters, there are two schemes to passing the parameters. Either you can pass the parameters by value or by pointer. You are familiar with passing the parameters using value. We have done it. But for pointer, after session 6, you will know about this. Actually, you're using the scheme passing the parameters by pointer. Can you give me the name of the function that you are using by passing by pointers of the parameters, passing parameters by pointer? The what? Loop is not function. Yes? Scanf? Yes, that's good. Scanf. Scanf, you pass the parameters by pointer. That's good. Pointer is very interesting, very powerful, but hard to control. It's like a knife, a sharp knife. Now, call by value. The caller and the function. When you call the function, you throw it with the value of the parameters. Okay. And let's say, instead of you see the caller throw a bone of the parameter to the function, but actually it's not the bone, it's a copy of the bone of the original. So the idea is that if the parameters is the function, this can be a number. This can be a number. You don't need to pass this as a function. Like the previous one, the edge function. come back with the function you want to add to function to number. Okay. Now, I will show you the code. Example, that we have a function like this. And for the first case, for the first time I call the function. This is called by the number, called by value. Both these two calls are passing by the parameters by value. But in case you input only a number, a value as an argument, it's nothing to say, it's trivial. It's nothing to say, right? So in case you call the function and input it two variables. So it means a copies of x, value of x, which is 6, and a copies of y, which is 5, the two values, 6 and 5, are input to the function addition. Input and compute the summation of these two values, 6 and 5. So these two times of calling a function is corresponding to the two cases that is mentioned in the slide. If the parameters is a number and if the parameters is a variable. Okay? Call by value demo. Yes. Convalescent. It's warm. This is the demonstration on Windows. In Windows, you will have the executable file. After calling the number is due, okay. You can try this. Yes, this can be better. I type it myself. Okay, now questions. What is the functions in this example and what does it do? Trần Hà Quang Vinh. Action. Trịnh Văn Quyết. Can you tell me the name of the function and what does it do?
The function is double file. Double 5 của 5
siêu thế. Đồng ý là nó là thế.
Thank you, but this is what I'm trying to say here. We are passing the parameters to a function, right? Passing a parameter to a function. And the parameters here is a variable. And in case it's the variable, the value of the variable will be copies. Okay? And this copies is input inside the function. So the value of the variable is not changed. It doesn't change. Over here, when you call double num my num, actually the double num will copy the value of my num, which is 10, input inside and computes double of 10 is 20, print out 20 from the function. However, the value of my num doesn't change after you call the function. Let's try. Okay, so you can see inside the function, a copies of 10 is input here. So it's returned 10 multiplied by 2, which is 20. Quick. I'm verifying your expression, your answer. And your answer is wrong. you have to check it. Now inside the function, the copies of 10 multiplied by is 20. But after calling the function, the value of the variable my num is still 10. Right? So you understand the scheme of create a copies of the value of the variable and input it inside the function. Now the parameters of a function can be a constant. Okay, even you copy the variable. For constant arguments, it's impossible to change the value of the parameters. Okay, and for this function, the argument is a constant. So when you call the function, you have to input it, the constant. Okay, and it's related to the pointer part. So we will discuss about this constant when we study about pointer later. 5 minutes break, okay, and then we come back for the product recursive function. Stand up, go out, drink water, jump, dance, run, singing, whatever you want to refresh.
Cô có dạy dance.
Tao biết đánh nhau.
Đánh ra đi bạn ơi. Đàn đi, đàn đi.
Right, let us continue. Only few slides left, and then you can leave for the weekend. Right, so please take your time to practice. Read the slide, practice the slide. Every slide here has a meaning, and I try to deliver the message to you. But I'm not sure you can catch this, or maybe you can catch only 50% or 20% the meaning of the message. So please take your time at home to read again the slide, practice on the example, in order to understand more percentage of the message we try to deliver in every slide. So we have mentioned about how to define a function, organize the function definition in separate file, how to call the function, call by passing the parameters by value and by pointer. And this part, the last part, we'll talk about recursive functions. Recursive function. I think you studied math about recursion. Recursive function. The idea is like this. Talking about recursive, that is mean we have to do some action repeatedly, again and again. But the input, let's say you call the function again and again with the updated parameters. And the recursive is the process of repeating in the self-similar way. It means you can call itself. The function called itself inside the body of the function. However, if the function keep calling itself again and again like this, it will never end. So for recursive function, it's very important that you have to define the exit point, the stop point for the repetitions. If you do not define the exit point for the loop, it will loop forever, and your program is hang. Be hang, lag, not lag, hang. Okay, so remember two things about recursive function. Firstly, it's called itself inside its body. Second thing, you always have to define the exit point to avoid the infinity loop. Now the fractional or the factorial function. To find the factorial function in recursive form. This is a recursive function. Okay? This function, what does it mean? Have a look at this and I call someone to tell me what does this function do? What is the task of this function? Who I should call? Lưu Đức Mạnh. Phí Mạnh Hùng. Okay, Hùng, could you explain? Can you see it, Will? What does it mean? What does... Firstly, what is the function? What is the name of the function? Secondly, what does it do? The task of the function. Can you see it?
Please find the factorial of n.
How do I find the factorial of n? Can you explain how the function computes?
Two.
How? Okay. Please. Okay, thank you. What he explained to me is correct. I can summarize this like this. We have a function. The name of the function is 5 factorial. And the task of this function is to compute a factorial of an integer number, a natural number actually, because it's unsigned integer. And in order to compute the factorial of n, this function will compute like this. If n is bigger than 0 and 1, it will compute the multiplication of this n to the factorial of n minus 1. And in order to compute the factorial of n minus 1, the function called itself inside the function. Let's say if we have n is 3, let's say 3, we call the function 5 factorial of 3. So at first, it will return 3 multiplied by 5 factorial of 2. And let's say the 5 factorial of 2 will check. It will return 2 multiplied by 5 factorial of 1. And when n is 1, it's continued till n reach 0. So the factorial of 0 is 1, and then it's returned all the computation. 1 multiplied by 1, so the factorial of 1 is 1. Factorial of 2 is 2 multiplied by 1, it's 2. factorial. 3 is 3 multiplied by 2. Continue like this. It's called the recursions. And this function is called recursive function. Okay? So this is how you define a factorial of a number by using create a function in recursive function, in recursive format. We call it here. Now questions. Recursive, so it's repeat, is called itself. When the recursion stop, what is the exist point of this program, of this function? When this function stop calling itself, what is the exist point? When n is 0, the recursion stop. So remember two things about recursive function. It's called itself, and you have to define the exist point, the stop point for the function to repeat. Okay, and then you call it as usual. The same task, but in non-recursive format. Non-recursive format is over here. The same thing to find the factorial of a number. Firstly, you have to make sure that the number is bigger or equal than 0, and then keep computing the multiplications of all the numbers smaller than this one. Okay, using the while loop. Right. So I think you can distinguish between non-recursive and recursive function. All the same thing here. Which one you prefer? Recursive or non-recursive of a function? Which one do you prefer? Let's say in the final exam, we ask you to write a factorial function to compute a function, to write a function to compute factorial of a number, and you are allowed to choose to write the function in recursive form and non-recursive form. Which format you will choose? Who choose recursive? Who choose recursive? Raise your hand. Only 1, 2, 3. Recursive. Okay, thank you. Who choose non-recursive? Few. What about the, thank you. What about the one who didn't raise your hand? You choose retake? Okay, so make sure distinguish between non-recursive and recursive, and be able to do both of them. And then you can choose recursive or non-recursive, depending on yourself. There are some pros and cons of the recursive function. Visually, intuitively, you see that the number of code when you run recursive function is less than the number of lines of codes or non-recursive, right? And it's simple. It's more simple than the non-recursive For non-recursive, the previous example, you see there you have to write several control flows with the while loop, and you have to compute again and again. So visually, the recursive function is simpler to write, and it's not nice. Less code, easier to debug. Because if the error occurred, only you can specify it's happened inside the function, and normally it's coming from the loop without the exist point. The code is short. However, for a recursive function, it consumes a lot of memory, more memory compared to the non-recursive. And all the time you have to face the risk of infinite loop. For simple problem, use recursive function. It's nice, it's logic, and provided that you always define the exist point. Remember, always define the exist, the stop point. I encountered the error of infinite loop before, and it takes me weeks to solve the bug. Sometimes to define the existing loop is not easy, because you have to define all the cases, all the situation, all the value that the function may return in order to define exactly what exist points. What are exist points of the loop? If you drop into the infinite loop, it's like you always find the exist, you cannot find where it is. It's quite abstract. Alright, so that's was about the recursive function. And it's now we have 15 minutes for practical time. You can try with your computer write a function to compute average of two numbers. I think it's not a problem. Next 2 weeks, when you study about pointer and array, I ask you to compute the average of 1,000 numbers. Now it's only 2 numbers. Write a program calling a bar function to compute average of 4 numbers. 1,000 numbers. Okay, go on. If you bring your laptop, you can practice. Bar function. Any questions? Any question? If you have questions, feel free to ask. You can ask in Vietnamese. Right? Feel free to ask. Utilize the time, practical time. Talk about programming, it takes time. Because it's a skill. Building the skills takes time.